Welcome back again, everyone. We're now going to shift our focus to the unit fraction. And we have mentioned in several of the sessions already that the unit fraction is quite the foundational piece that is moving through, starting right in kindergarten. We don't use the word fraction. We certainly don't use the word unit fraction. But when they start to share, if they're sharing equally out money, that's a form of a fraction already, although we don't talk in that language. In grade 1, they look at halves, the word half, not the 1/2. They're looking at what is a half? What is the meaning of a half? Where do I see a half in day-to-day world living? And what constitutes an equal portion? That would be the matching half. So, typically matching Valentine hearts, if you cut them in half, or you've got a square, who's got the other side, whatever the shape is, what's the matching piece to it, the other half of it. But by the time they get into grade 2, that half does become a 1/2, and it doesn't become a numerator denominator. It becomes more of, I have one out of a total of something, one out of, and it's just the focus on the unit fraction. And typically we've always taught unit fractions. We just maybe haven't given them the due diligence that they should have gotten. And I'm going to make a guess that once our students start to come through the new program, and if we are really emphasizing the beginning and understanding of a unit fraction, everything that they do in fractions should come into play and make more sense to them, because they are going to be doing fractions that they normally would do in junior high. Right now, they're doing those in grades 5, 6, but they have to understand what it is. It isn't about showing me a process of finding a number and a denominator. It's about understanding what that is first. So that's where we're going to start, with the unit fraction. And since money is going to be so prevalent for us, and the kids are using that as a big tool to use for understanding, then why wouldn't we use the money to do the same thing? So I'm going to flip my sheet over here. And what we're going to do is we're going to move to a large number line. Now, this number line comes from a company called Didax. And what you get is a strip like this. On one side, it goes from 0 to 100. On the other side, from 0 to 120. They are hard cover, or sort of hard cardboard, and they're shiny. They're laminated, so you could use a dry erase marker on them. But what I really like about them is that they're big enough that we can do a lot of things on them. Namely, I can do money. So let's talk about some things that students are quite familiar with. And keeping in mind that if I'm going to be starting with unit fractions in that younger grade, even of a grade 2, then I'm going to start with my money, and I know that I can skip count by tens. So if I said to them that this went all the way across to 100, what do we already know in money is equal to 100? And the kids will tell you very quickly, right, even in grade 2 up, that it's the same thing as a loonie. Great. So I'm really showing what a loonie is made up of on this number line. And then we could actually ask them, let's just see how good they are at rationalizing and comparing the physical tool to what they're seeing. And I would ask them, what do we know that we have a coin that we could skip count by that would give us these numbers? I'm not skip counting for them. I'm showing them. So I really want them to think about what I've just pointed to. And they will say to you that those are like dimes. So I will ask them, find a dime, and can you put a dime above each number that you would use a dime for if you were actually skip counting by dimes? So that's what they're going to do. They're going to put them on top. And we do this. We have it in front of them so that they actually would sit down and work us through. Now, if I have a student in 4, 5, 6, and I'm still struggling with fractions, I would go right back to the very beginning. I'm going to take my loonie off because that's actually one of the places for my last dime. So I would ask them, tell me again, how many dimes did you say go into a loonie? And they'll say 10. And how can you prove that to me? Well, we could count them. I said, okay, that's great. So you could count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Can you also show me another way that you can prove to me that it's a loonie? Well, a loonie has 100 cents. So if we skip counted by 10, then I could get to 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Excellent. And always ask them those kinds of questions, because that reverse, how can you prove it to me? Well, because it fits. Okay, it fits. I see that. Now, what if I didn't see it? How else could you prove it to me? So it's just making them think intentionally about, what have I already learned that could answer the question that she's asking me? So now I might say, you just told me that we have 10 dimes. So this dime that is sitting right here in the first position is my first out of 10 possible dimes. So it's represented by the unit fraction 1/10. Now, the other thing about a unit fraction is a unit fraction is always measured, tells me the distance from 0 to that first value. So that's how big 1/10 is on this graph with the dimes. So I would expect that every 1/10 jump, every jump I make to each successive dime should be exactly the same distance, which of course it is. So then we would say to them, so if I jumped by 1/10 to get to this one, how many dimes have I used now? And they'll say, well, that's 2 out of 10 dimes. Oh, okay. So then what would this one be? 3 out of 10. Well, then they get the pattern, right? And that becomes a pattern. So we can have them fill in their pattern. And we could ask them, could you prove to me that you did exactly go the same distance? Well, they could say, well, the lines show it. Yeah, that's one way. They could take a piece of paper and measure the distance from here to here and show that the jumps are the same. Yeah, that works. But in any case, I've got them labeled. This is my unit fraction. This is my first starting point. So what this is really saying is I took 2 unit fractions, 2 jumps of 1/10 to get here. This was 3 jumps of 1/10. And the reason I'm saying that to you is because as I talk about that with students, some of your students will write it that way. That's what they will say. I did 1/10 jump. Now I've done 2 1/10 jumps. Now I did 3 1/10 jumps. Now I did 4, and so on. And they will write them something like that. They may not necessarily put the bracket in. I will show them that at some point if that's how they're counting, because they'll just go 2 and a 1/10. So I always say, can you explain that to me? What does that mean? Is that 21? No, that means I had 2 1/10 jumps. And then I did another 1/10 jump to get here, and then did another 1/10. Perfect. So maybe we'll put a bracket around it so that you, or parenthesis around it so that you can see that it's not stuck together that way. They don't know anything about this as multiplication. They don't, that's not even important. We're not into that yet. But they will intuitively write it that way because that's how they're counting. So then I will maybe go over here and say, what did you notice about the last one? Oh, well, it's 10 out of 10. Why do you think it's 10 out of 10? Well, because we got to this part here, which is the last one. It's the 10th one. And it also made 10 dimes would make a loonie. So if this was all 10 of them stacked together, we would trade them for a loonie. Perfect. That's the kind of conversation we want to have with students. Okay. So that's a unit fraction of 1/10. That's an important one, right? The 1/10 is important because if we're going to start talking about decimals and tenths in grade 4, then I better understand what 1/10 even is before I do something. So the other one that's in our base 10 kit, I could do nickels, and I do nickels with the students, but 20 is a big denominator, and it's not necessarily in the grade 2 curriculum, for sure not. It is in grade 3. But let's do the one that is obvious for them. I might ask them, what do you think each one of these lines are? So you told me that these were the dimes. So what do you think these small little lines are? Or some of them will say, there's longer ones in between. Okay, well, what do you think the longer ones in between are, right? So asking them, not telling them. And you will have students that will say to you, well, those are all the individual lines that if you counted by 1, will get you to 100. Okay, so what do we have that we could count by ones? Pennies. Okay, now pennies don't fit nicely side by side on here. That was one thing that we determined. And the kids try. They try really hard. So what we kind of came to a conclusion is you could stack 5 of them at every 5, or what most of the kids did is they stacked 10 of them on the 10s. But we left 1 on 1. And the reason I want to do that to start with is how many pennies do I need to get over here to my loonie? You said my loonie lived at 100. How many pennies do I need for a loonie? 100. So then this is my first penny if I laid them all out of 100. So this first line right here, I'll just do an arrow down. That first line is my first penny out of 100. That's a unit fraction. A unit fraction is defined by anything that has the numerator of 1. So there's lots of different kinds of unit fractions, and they can look very different and still have the same number on them, even though they don't represent the same quantity. That's a different conversation to have later. So I would have 1/100th jump to get to this line. I do another 100th to get to this one. I do another one, I get to this one, and so on and so on. So then if I jumped that many times to get to the 10, what does that represent? Well, it was a dime. Or how many pennies would that be out of 100? It would be 10 out of 100. So again, you can kind of see where we're going. We want them to think in terms of pennies now. So they're going to fill in the whole top row, and they're going to figure out they get 100 over 100. Okay, powerful. And every child can be in part of this. This is not something you're going to lose them. It takes them a little while to get their bearings about what we're doing with the 1/10 or the 100th, and that's fair because they have never thought of it in that term before. Okay, so now we're going to do one more, and I think I did away with mine. I did away with mine. I apologize. I'm just going to put me on pause here. I'm going to go grab a quarter. So get your quarters out if you have them available to you, because we're going to use those right away on the bottom line. Okay, I am back, and I actually found real quarters that I'm going to use for now. So the quarters are interesting because they're one of the most powerful coins that we can work with the students for a couple of reasons, and we're going to unpack that right away. So, of course, we're going to ask them, what's a quarter worth? 25 cents. Where would you find 25 cents on a line? So they should be able to see that, and some of the students will count by ones, and then that's something for us to note, that they're not intuitively knowing that it's halfway in between, right? So that's something that we can pay attention to. So here I have my 25. If I go another 25, how much is 25 and 25? 50. My next one would be at 75, and then I have my loonie. So we asked them, how many quarters did it take to give you your loonie? 4 of them. So what is the first quarter going to be? And this time I'm not writing it first. I'm asking them to tell me what it would be. And they will say, it's the first one out of 4. Very good. So this is my first one out of 4. And this is my second one out of 4. And this is my third one out of 4. And this is my fourth one out of 4. Or I got my loonie. Now that quarter is something that they probably encountered in a lot of different ways. In grade 2, they do quarters, the word, they do the fraction, they flip paper full, they take a square, they cut it in half, they look for quarters, visuals that are quarters, etc. So by the time I get to grade 3 and I'm allowed to use denominators up to 100, right? I'm not adding fractions. I'm just using unit fractions in that context. I could do a lot of different possibilities. But in the real world, we don't deal with 1 over 11, and we don't deal with 1 out of 13. We deal with some pretty common fractions. And as they explore those fractions in grade 3, they also introduce them to the imperial system. So 1/4 is a big one in the imperial system, as is 1/8, as in 1/16, 1 over 32. So they will use that to start understanding what an imperial ruler looks like versus a metric ruler. So this foundational 1/4 becomes really, really important. And at some point, we want them to recognize that 5 out of 10 is the same thing as halfway there. And I would ask them that question at some point, not right off the bat, but I might say, you know, there's a coin, and we don't have them in the play sets, but we can show it to them virtually. There's a coin called a 50-cent piece. So where do you think that 50-cent piece is going to go? Well, clearly above the 50. Well, where's the other one going to go? Well, over here at 100. So what's that first 50-cent piece? 1 out of 2. So I'm just going to draw it up here because I have that conversation with them, even though they've never seen one or can't give them one. The 50-cent piece is sitting over here, and it's the first one out of 2. And over here, I have another 50-cent piece, and it's the second one out of 2. So that's important that we could have a conversation of, so you're telling me that one 50-cent piece would be the same as 5 dimes out of the dollar. Yes, because I can count them and I can see them. I'm at the 5th place. And that would make sense, 10, 20, 30, 40, 50. Where I'm going to with this is that we want students eventually to understand that a half doesn't necessarily have to, it represents the same ratio, the quantity, but the total, the amount that it represents could be different. So the half of 100 could be very different than half of 10. Both of them are halves, but they don't represent the same whole to start with. So that's a really important distinction. Now, you're not going to do that with grade 2s and grade 3s right off the bat, but in grade 4, 5, 6, we sure are. We're going to ask them that at some point once we start moving forward with these unit fractions. So understanding how to find a unit fraction is really important. And once they've done some of the basic ones, then we can get a little bit more adventurous and we can say to them, well, kind of know by looking at how many different pieces there are on a number line that we have to break it up. Then we can decide how to write our unit fraction. Then we can ask them to do some deeper thinking. So let's have a look at a possibility of what that might be. Just going to slide mine out of the way here. And I'm going to bring this down just a little bit for you so it's easier to see. Okay, so we're still in the money, but I want to show you how we might go one step further and use the visual of the money. So I would actually still have their number line sitting out beside them if I were to bring this out. So this would be more of a grade 4 step up now with the unit fraction. So I might say to a student, if this is 0 and this is 1, can you find me what the unit fraction would be that we would use to get to here and then to get to here? And so they'll say, well, there's only 2 hops. So this is your first one out of 2, and this is your second one out of 2. Okay, fair enough. And then I'm not going to give them any more hints other than to tell them that down the left-hand side is always 0, the starting point, and down the right-hand side is all 1. So they're all measuring the same 1. It's just that each line got cut into different sized pieces. So what will I write for this one? Well, I had 1, 2, 3 hops to get to the 1. So my unit fraction would be 1/3. Another 1/3 would make it 2/3, or some students will write the 2 and a 1/3, and this would make my 3/3. And they do like these. These are fun for them to do. I'm not going to suggest that they completely understand at that point what they're doing, but we're going to bring money back into this right away here. So here I have 1, 2, 3, 4. So 1/4, 2/4, 3/4, 4/4. Well, let's check this one. 1, 2, 3, 4, 5. So I would not be doing this with them. I would be walking around. I would have them have shoulder partners checking, talking to see what they're coming up with, and certainly listening formatively to see, are they really getting what they're supposed to get out of this? And we're going to get down to the bottom here, which is then going to move us from 4 into 5. So I've got 1, 2, 3, 4, 5, 6. And the last one, 1, 2, 3, 4, 5, 6, 7, 8. So this is their imperial one. And in the grade 3 math kit that is online, we do have the imperial ruler there for you to pull off for them, that they can do the labeling and that they can see it. So now I have these values of my unit fractions that have gone through. And I can say, are these hops, this 1/8 hop, consistently the same? Okay, and they should be able to talk to me about that. But now I might say to them, does any one of these rows represent any money? So now they have to think, is there any one of these rows that could be a money value? Well, the first one could be the 50-cent piece. First 50-cent piece, second 50-cent piece. They have to think about this one. The threes often throw them off, but I let them muck around with it, let them try. They'll take their money out and they'll try it out. This one, they start to recognize. This is my quarters. Okay, the fifths. They'll first say nickels. So again, if that's what they want to say, then I might say, okay, so if this is the first nickel, let's count by fives. 5, 10, 15, 20, 25. Is that getting me close to 100 or the one that I need? And the answer would be no. However, I am going to give them a hint and say, but there is some money that you have that will give you this amount. So eventually, it takes a little hunting on their part. They realize that it's the $20 bill. 1, 6, 2, 6, 3, 6, 4, 6. They find that they can't find anything to match that one. And the same thing happens down here. So trying to make connections for them so that they're understanding that every way that we write it doesn't have to have money in front of them, but I can equate it to money at any point in time. This would be a good grade 4 conversation, right? All of them ended at 1 because they don't go larger than 1 in grade 4. So anything I do with money, I'm going to have an end point for them, 100 cents, 1 loonie, whatever. You have an end point, $100 bill that you're going to divide up, but it's still the unit fraction, and it falls between 1 and 10 in the denominator. So we're good to go there. But what if, and I'm not going to do the whole page, but what if the question sheet had a few changes to it? So what if I had, in the end, changed where the 1 was? So this would be a great grade 5 conversation. And we're going to bring money back into it as well. So again, I'm going to ask them, I'll do the first one with them. You have 2 hops to get to 1. So they'll say, that's my first one. This is my second one out of 2. But now I say, oh, here's the 1. So what is, you went from here to here and here to get to the 1. So how many hops was it? They'll say, well, it's like the top one. Oh, okay. So if it's like the top one, here's my first out of 2 hops. Here's my second out of 2 hops. Oh, and I get to make 1 more hop. So it's my third out of the 2 hops. See where we're going. So I went by 1/2 hops each time, and I did 3 of them to get to this one. So then we do this one. Oh, it's another one that's just 1/2. There's the 2 out of 2. This one is 3 out of 2. This one is 4 out of 2. So the idea is that we're using this to leverage in grade 5 the conversation about improper fractions. Improper means I get to keep using my unit fraction and keep jumping beyond 1. I don't stop when I get to the whole. I keep going. And the advantage of doing that is if I come down to the one at the very, very bottom here, I have 1 quarter, I have 2 quarters, 3 quarters. Here's my 4 out of 4 jumps, my $1. Here's 5 quarters, 6 quarters, 7 quarters, 8 quarters. Now, remember I had said at the beginning that the quarter was the magic coin for us for fractions and numbers. So is the dime, but the quarter in particular. Because if I'm going to introduce my quarter back to them, here's my quarters. When I get my 4 quarters on there, what have I learned? Well, I've learned that I have got my $1. Okay, I've got my 4 out of 4. I could have replaced it with a loonie. But now I've got more. And this is the nice thing about the quarters. They can hold this in their hand. They can see it. I got 5 quarters. I got 6 quarters in my hand. I got 7 quarters in my hand. So then what do I have in my hand? I have a loonie, which was these ones taken away. And I have 3 more quarters, which is 75 cents. I now have $1.75. I have 7 quarters. I have 7 quarters in my hand if I take the loonie away. So I now have the advantage of being able to say that this is the same thing, when I get down to here, is the same thing as saying I have 7 quarters, right? Count them all up, 7 quarters. I have $1.75. So I've now taken my improper fraction of 7 quarters and written it as a decimal because I can count that out in front of me. Or I have a mixed fraction of $1 and 3 of my quarters to get to the next dollar. So the quarter is a magical connection between improper decimal and mixed fractions all at the same time. And that is the magic of money. We can tell you improper fractions are the numerator, which is the top number, is the biggest one, and the bottom is bigger than the denominator, which is the bottom number. But if that's not intuitive for a child, you can tell me that all you want. It doesn't make any sense. And in this one, I can also say, well, is a half a half? Of course it is. I say, okay, so all of these halves look exactly the same to you. No. I said, well, you told me a half is the same. Well, it's the same number of hops, but it depends on how big the line was, right? So we're getting to the different sized whole can be represented by the same fraction, but the amount that it represents is different. I could ask that of 18-year-olds, and some of them won't get that right off the bat. So power of money, use it for unit fractions. Use it first, introduce them, get them really good at unit fractions, then move to some abstractness in grade 4 where they're all working to ones, and then move them a little 5, because in grade 5, we also want them to be able to understand that any fraction that I write, for example, 9/8, is really the same thing as saying I did 9 hops of 1/8. But they have to be able to pull out what was the unit fraction. How many of those unit fractions did you need? And because they're adding like denominators in grade 5, then we could ask them to write 1/8 plus 1/8 plus 1/8 9 times. And that's legitimately what they're doing in grade 9, same denominator. When they get into grade 6, they can have unlike denominators. Okay, so I hope that gives you a little bit of insight on how you might maneuver some of the money to have discussions about fractions. Very, very powerful tool. It opens up a lot of eyes and gives students a little bit more understanding about the things that we've been trying to talk to them about. All right, thanks very much, everyone.